Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at what makes a relation a function. So before we can do that, let's talk about what a relation is. So a relation is defined as anything that can be represented by a set of ordered pairs. So ordered pairs tend to be of the form x, comma, y, or more generally, input, comma, output. And so if we have a whole set of inputs that are related to particular outputs, we call that set a relation. So let's take a look at one example of a relation. So here we have the input being the month number. So that makes 1 for January, 2 for February, 3 for March, 4 for April, and so on. And the output, or the item that is related to that input, is the number of days in that month. So the output here for January would be 31, because there are 31 days in the month of January. The output for input of 2 is 28, since if we're considering non-leap years only, there are 28 days in the month of February. And so on, it repeats in that fashion. So that's one example of a relation. If we think of relations as kind of a big box that all these different relationships can fall into. So let's think all the relations are kind of in this box. Then inside that box is a smaller box that has some boundaries on it, and that is where we get functions. So functions are relations, but they are relations that have a specific limitation placed upon them. And that limitation is that a function is a relation that has one output value for each input value. So if we think about a map, okay, if we think about here's our list of all our inputs, here's our list of all of our outputs. Let's say we have 1, 2, 3 here and 1, 2, 3 here. Then what a function limitation says is that this particular input, can only be mapped to one of the outputs. Now, it doesn't matter which. Okay, it could go to 1, it could go to 2, or it could go to 3, but it cannot go to 1 and 3. It can only go to one output. So that's what makes it a function versus a relation where each input can go to as many outputs as we want. So let's take a look at some relations and see if we can determine whether or not they are functions. So here's 3 different relations. So in our first, we have a list of ordered pairs. Over here, we have a table of x values and y values. And then third, my personal favorite, we have a list of colors of jelly beans and their flavors. So let's start up here at the top. Let's start with just these list of ordered pairs. So what I want to do to check if I have a function is look at my x values first, or all of my input values. Check for any repeats. Okay, so here I have 0, 1, 1, 2. So my eyes are drawn to 1 and 1 as repeated inputs. So if this is going to be a function, then that single input, 1, can only have one output. Here, 1 has an output of -2 in our first piece, and 3 in our second. So because we have one input, the number 1, with 2 different outputs, this one is not a function. Okay, so we have a repeated x value with different y value. That's a no-no. Okay, let's check our table next. So first, again, check your input values, look for repeats. So I have 0, 3, 4, 8, 3. So again, I do have a repeat. I have 3 listed twice in my x values. So what we'll do is we'll then compare the associated outputs. In this case, they have the same output. So 3 matches with 1 and 3 matches with 1. That's okay. Each input can only have one output in a function, and that's what's happening here. The input 3 only has the output 1. So this one is a function. All right, checking out our jelly bean example, what we're going to do is first list or check out our inputs, see if we have any repeats. So we have red, orange, yellow, green, purple, and black. So here, because I don't have any repeated x values, there is nothing for me to check. It must be the case that each input only has one output, because each input is only being matched with a single flavor. Each color only has a single flavor, and I don't have any repeated colors. So this one is a function. Now, of course, instead of only being given the values here, another way that we're very used to looking at relations is on a graph or a visual representation of relationships. So when we want to determine whether a graph represents a function or not, we have a very particular test that we can use, and that is called the vertical line test. And what the vertical line test does is it checks for inputs that have more than one output. And so the way that the test works is along your graph, you're going to take vertical lines and you're going to check. So imagine taking a vertical line and passing it through your whole graph. If there is anywhere that you could draw a vertical line that would touch your graph more than once, then that graph would fail the vertical line test and it would not be a function. So here, notice, no matter where I drew my vertical line on my parabola here on this first graph, it only ever touches at one point. That means each x value along my x-axis only has one y value on this graph. So this one is a function. It passes the vertical line test. Taking a look at my circle here that I have, here, let me just draw any random vertical line and notice that vertical line is touching my graph 1, 2 places. So that means that this graph has x values with more than one y value. Or we can say that this graph fails the vertical line test. So this is not a function. All right, and then lastly, let's take a look over here at this function. This is an example of what we call a piecewise function, which we'll study a little bit later. And it's got pieces, right? So when we go, we're going to look carefully at everywhere that we could draw a vertical line. So if I imagine drawing one all along here, this left piece is fine. When I get right here, though, if I draw a vertical line when x equals -2, I see that we are touching the graph 1, 2 times. So that means at x equals -2, we have 2 different y values. We have one x value with multiple y values. So this fails the vertical line test. This is not a function. Alright guys, that does it for this video on Introduction to Functions. We'll catch you in the next one.